Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Hizar Aftab, a third year mechanical engineering student at UET Texla. My registration number is 22ME52. Today here I am giving the final video presentation under the course Engineering Economics. So I have divided this presentation into four major parts depending upon the course learning outcomes. So starting from the very first, the CLO-1, here I will discuss about the basic engineering problems, their solutions by the discounted cash flow methods. So before solving any engineering problem, it is better to understand that what are discounted cash flow methods. So it is basically a method that is used to find the future cash flows by converting them to present. So the formula here is as given. In this formula, PV is representing the present value. The future value is represented by the figure F. So here I is representing the interest and N are the total number of years or the total lifetime of the project. The major question arises here is that why we are using this formula for converting the future value into present value? Why we are not just adding the future values to get its present value? So it is because of the time value of money. So time value of money means that the value of money is varying from time to time. If I give an example of my childhood, like in 2014, the value of United States dollar was nearly 99 to 100 rupees, Pakistani rupees. But for now in 2025, the value of dollar is varying from 275 to 280 Pakistani rupees. So in this way, the value of money is varying from time to time. Like in this example, the present value of the 60,000 rupees of after 5 years is nearly 37,255. So it is better to take 50,000 rupees in today instead of taking 60,000 after 5 years. So here I am giving the use case of P by A factor. When the future cost in any cash flow diagram are all same, means they are considered as the annual operating costs or the annual cost, because the annual costs are uniform throughout the series. So we can use this formula. Here in this formula, P is representing the present worth of those annual cost amount. So the annual cost is representing by the figure A. So here I is representing the interest rate and N are the number of years or the total lifetime of the project. Now I am considering another important case, that what will happen if the cash flow series are not uniform. Will we use the P by A factor again to find the present value of those amounts, or will we use another method? So here we cannot use the P by A factor, because in P by A factor the A amount is constant or uniform throughout the series. But here the future values are varying from year to year. So here we can use another method, that is using the P by F factor. So here the F value is that value that is varying from year to year, or it is representing the non-uniform cash flow series. So the P by A factor is valid only when the cash flow series are equal and occur at the regular interval of time. So for better understanding the difference between the uniform and the non-uniform cash flow series, I have added the following two figures. The first figure is representing the uniform cash flow series and the second figure is representing the non-uniform cash flow series. The reference of these figures is added at the bottom of the slide. So if we see in the very first figure, the amounts throughout the year is same. So means that this is representing the annual amounts. So these all values can be considered as A amount, and we can utilize the P by A formula to find the present value of all these amounts. Now, if we see the second picture, here the annual amount or the amount at each year is varying. Like if we see that the amount at the year 1 is greater than the amount at the year 2, then it is first it is lowering and then it is rising. So the amount at each year is different. So here we cannot consider them as an A amount and then apply the P by A formula to find the present value. So here we consider all of these values at each year as an F amount as the future value, and then we utilize the P by F formula to find the present value of all these cashiers. Now I am going to explain the basic difference between the two different type of interest. These interest types are the nominal interest rate and the effective interest rate. So nominal interest rate is basically a simple interest rate that is stated yearly. So it doesn't include that how much the interest is compounded in a specific period of time, or how often the interest is added. So moreover, the effective interest rate is basically the interest rate that updates its value after the compounding period. Like if we see in this formula here, IA is representing the effective interest rate, and I is representing the nominal interest rate, M is representing the compounding period, that after how much time the interest is compounding throughout the year. So by explaining it with the help of example, we are given with the nominal interest rate, that is about 12%, and we are also given with the compounded period, that the interest is compounded quarterly per year. It means that every after 3 months it is compounded. So here if we put these values in the above given formula, we find that the compounded interest rate or the effective interest is 12.57%. So what we conclude from this calculations, that the effective interest rate is a kind of interest rate that is somehow greater than the nominal interest rate. So the reference for all these stuff is I have taken from the engineering economy book. I have mentioned the page number, which is nearly 994. So here I have explained the method that if we are given with any amount that is placed in future, either it is a single amount or a series that is placed in the future. So how can we calculate its equivalent value? First of all, we have to identify whether it's a uniform cash flow series or non-uniform cash flow series. Then we have to choose the appropriate interest rate, or either we are given with the interest rate. Then we also have to determine the number of periods, that for how much year the project is projected. So then we can all put the formula, that is either P by F formula if the cash flow series is not uniform, or the P by A formula. So the overall process is called the discounting. So it is basically the application of discounting cash flow method, from which we can calculate the present value of any project, or any cash flow series in which we are given with the future amounts. So what we conclude from the previous slide, that the key variables that involved in the formula, number one is F. Here F is representing the future amount. The second one is the interest rate, and the third is the number of periods. Now I am going to explain the engineering economic equivalence concept, which is the very last topic under the CLO1. So it said that the two cash flow series are always equivalent to each other if they have the same value at a specific point in time. So why it matters while working on an engineering project? We know that the benefits and the de-benefits are the part of project. Sometimes we may get a profit from the project, while on another time we may get a loss. So it is better to bring all the cash flows at the same time, and then deciding what to do with those projects. Like if we are having a machine A and machine B, the cost of machine A in the present value is 1 lakh rupees, and the cost of machine B is 1,20,000 2 years ahead. So we cannot decide that what to do with these both machines, like how to decide that which machine we should buy. Now let me explain this concept with the help of an example. We are having two options, option 1 and option 2. The cost of option 1s are as stated. The option 2 present value is 18,500 rupees. Then when we apply the present worth formula on the option 1 and calculating its present worth, we calculated it is nearly about 18,000. 17,975 rupees. So at this point, these both projects are in engineering economic equivalence with each other. It means that the value of the both project is same. Now moving toward the course learning outcome number 2. Here we will compute the capital recovery, net present value, and rate of return for the mutually exclusive as well for the independent projects. So the capital recovery, we will also discuss that what are the factors that are involved in capital recovery. So by the definition of capital recovery, it is basically the minimum annual amount that the project must have to earn in order to recoup or recover the initial investment as well as the salvage value. So if we take this example here, the present value is 20,000, salvage is 5,000, number of years are 5. So if we calculate its capital recovery at an interest rate of 10%, we found that it is 6,532 rupees. It means that from year 1 to year 5, the project must have to earn minimum 6,532 rupees in order to recoup or recover its initial investment. So now let me explain how minimum acceptable rate of return is influencing the capital recovery. So it is basically the rate of return at which the project must have to earn some amount in order to recover or recoup the initial invested amount and its salvage value. So from the previous formula, we see that MAR is directly proportional to the capital recovery. Greater the MAR is, greater would be the capital recovery. In this example, if we see that at a MAR of 8%, the capital recovery is 1,25,000 rupees, and at a MAR of 12%, the capital recovery is 1,38,000. So as we increases the MAR, the capital recovery is also increasing. Now, what is net present value? It is basically the difference between the present value of the cash inflow and the outflow. So what is the decision rule for an independent project? Suppose we are having an independent project. If the net present value of that project is greater than 0, then we can accept that project. And if its net present value is less than 0, then we can reject that project. For mutually exclusive projects, we have to select a project whose present value is numerically largest number. Now let me explain this with the help of examples. Suppose we are having 4 different projects whose present worths are as given. For mutually exclusive case, we will select the project A because its present worth is numerically largest. For independent case, we will select those projects whose present worth is greater than 0. So in this case, we cannot select the project C as its present worth is less than 0. Moving toward the next topic, that is the rate of return. So it is basically the interest rate at which the net present value of all the cash flows becomes 0. So decision rule for independent project is that if the rate of return is greater than the minimum acceptable rate of return, then we can select that project. And if ROR is less than MAR, then we cannot select that project because that is not financially viable. There is a problem with calculating the ROR for non-conventional series because in non-conventional series there are a number of sign changes. So with the possibility of number of sign changes, there is a possibility of the root of the rate of return. So what to do with these kind of series? So we are having 2 different methods. Number 1 is the discount rule and the second one is the Armstrong criteria. Discount rule says that in any net cash flow series, the roots of the rate of return would be equal to the or less than to the number of the sign changes throughout the series. Moreover, I will explain the Armstrong criteria with help of an example in the next sections. So here is the summary what I have presented before. For independent projects, we have to choose all those projects whose ROR is greater than the minimum acceptable rate of return. So for the mutually exclusive projects, we have to apply the Armstrong criteria in order to find the suitable project. So here is an example for calculating the IRR for an independent project. Here present worth is 20,000 rupees and the annual worth is 7,000 rupees. So by applying the formula in Excel, that is IRR, then first cell throughout the last cell of the series, we calculated that is the internal rate of return is 18.2%. So that is greater than the minimum acceptable rate of return. So as considering it as an independent project, we can accept this project. Now I am going to explain the IRR method for solving mutually exclusive projects. Suppose we are having 2 alternatives, alternative A and alternative B. So first we have to arrange them in order of increasing their initial investment. Then we have to find the incremental cash flow series. Then I have find it out the present worth of this incremental cash flow series by plugging in the different values of interest. So here is the summary table that I have plugged in different interest rates in the incremental cash flow series in order to find its present worth. So here what I find out that between the interest rate of 35% and 40%, the series is changing. I mean that the series is converting from positive side to the negative side. Then I draw the graph in order to calculate the interest rate at which exactly the present worth of the incremental cash flow series is equal to 0. So I get the value of 38.13%, and this is the value at which the present worth of the series is equal to 0. So here the I steric is greater than the minimum acceptable rate of return, so we can select the project B. The previous example that I explained is that the lifetime of both the projects was equal. But if the lifetime of both projects is not equal, then we will take the LCM of the lives and then make the series up to the LCM of the lives of the both projects. So here are the general steps in order to find the internal rate of return for the mutually exclusive projects. So first we have to arrange the alternatives by increasing initial investment. Then we have to develop the incremental cash flow series by using the LCM of the years. Then we have to count the number of sign changes throughout the years. In previous example, the sign change was only 1. That is from the initial investment and then from year 0 to year 1. then we have to select any criteria, like if we find out the present worth or the future worth, then setting up by plugging in different values of interest and then checking that at which value of interest is present worth is equal to 0. Then checking or comparing that interest rate value with the minimum acceptable rate of return. If the value is greater than the MA or double R, so we can select the project B, or the project that is placed on the extreme right side. So if it is not greater than MAR, then we can select the project which is placed on the left side of the series. Now moving toward the cost learning outcome number 3, which is the computing the life cycle cost of the various projects. So life cycle costing is basically economic process in which involves any kind of all kind of costs that are associated with the project through its lifetime. So the main components of LCC are the acquisition cost or the initial investments, then the operation and the maintenance cost throughout the life of the process, and then the end life or the disposal cost of the project. So now here we will compare two different designs, and then we see that which design is better to invest. So for example, if we are having design A and design B, design A is having low initial investments and high maintenance cost, and the design B is having the high initial investment but low maintenance cost. Now, how to compare both of these projects? So we find the present worth if the lifetime of the project is equal. I mean that suppose that both of projects are projected for 5 years, then we will find out the present worth of both the projects, and then see that whose present worth is greater or numerically largest, and then considering that project. So present worth gives a biased result if the lifetime of both the project is not equal. So here what can we do? If we can take the LCM of the years of the project and then making the cash flow series up to the LCM year. The second one method is that using the annual worth method, we calculate the annual worth of both projects and then selecting the project which is having higher annual worth. So for annual worth analysis, we do not have to take the LCM of the project, because in annual worth the cost is constant or remains same throughout the years. So present worth gives biased result if the lifetime is different. It is because, like if we take an example, suppose we are having two different projects whose lifetime is 5 years and the other one whose lifetime is 10 years. It is absolutely sure that the lifetime of the 10-year project would be greater than the 5-year ones. So we cannot directly compare them. First, we have to match the total lifetime of both of them and then comparing them by calculating the present worth. So these are the non-monetary or the qualitative factors that are included in the financial evaluation. The first one is the environmental impact. Suppose if we are planting a project, we have to see that if there is any kind of emission from the project or not. Then the safety and the risk, and the third one is the social acceptance, that are the communities accepting it or not. Then the fourth one is the acceptance from the governance, that the governor will approve it or not. And then the long-term sustainability. So a feasible project may still be rejected if it has negative impacts. So break-even analysis. Break-even analysis is basically a method that is used to find the point at which the cost of two systems becomes equal to each other. Suppose we are having a machine A and machine B. Machine A is high initial cost, but its maintenance costs are low. And the second one is whose initial costs are low, but maintenance costs are higher. So here what we need to do in order to select any of the machine, or in order to purchase any of the machines. So here we have to see some factors like for how much time the machine will be operated. So here is the formula for calculating the total cost of the project. It includes the fixed cost plus variable cost into quantity. Here the quantity is basically the key variable. It means that for example, if a machine is producing some kind of units, then how much unit it is producing, then how much hours it is operated, and for how much years it is in service. So these are the factors that influence the break-even analysis. Now I am going to explain the very last topic of my presentation, the CLO4, in which I will be developing the economic solutions for the project in a real world simulation. In this case, I will consider a company who is deciding to invest in the robotic arm, and also it is considering that while the manual or the semi-operated lines are already installed, so whether they maintain those machines, or will they invest in the robotic arm. So here are the important key factors that I need to know about in order to do the engineering economic analysis. The first one is the initial cost of the machines, that for how much cost the machines are purchased. Then the second one is the operating and the maintenance cost. It is quite sure that the maintenance and operating cost of the robotic arm project would be higher than the one that is on a manual lane or a semi-operated lane. Then I need to know about the taxes that will be employed on both the projects and the depreciation of the projects. Then I also need to know about the salvage value or the disposal value of the old machine. Then the useful life, that for how much time these boats will be projected, and then the minimum acceptable rate of return for these projects. So here is the details of the methodology. I am considering two alternatives, alternative A and alternative B. So alternative A is keep using the current manual line, and alternative B is investment in the robotic arm. So I will process the calculations as per according to the following headings. Number one is cost estimation. I will estimate the cost of each of the project. Then I will calculate the depreciation for each of the project. Then I will employ the taxes that I have considered roundly 30% on both of the projects. Then I will calculate the cash flow before tax, and then after subtracting the tax from the cash flow, then I will find the cash flow after tax, and I will also perform the sensitivity analysis, and at the last I will recommend that which product the company should have to invest. So here is the detailed distribution of the cost for the alternative B. Here I have considered the initial investment cost, then the annual operating cost, and then the labor cost. Moreover, I have also considered the intangible or the indirect cost, and then the disposal cost. The initial investment for the alternative B or the robotic arm project is 1,85,000 rupees. Now moving toward the alternative way, its distribution of cost is also somehow similar. Here I have also considered the annual operating cost and the indirect cost related to the project. Here the labor cost would be higher because on a manual line or semi-operated line, more number of laborers would be required. The initial investment for this project is 82,000 rupees. So here are the details of the depreciation for the alternative B robotics arm. So the depreciation method that I have selected is the modified accelerated cost recovery system, the MACRS depreciation method. So this method is given by the Institute of Revenue Services, United States. Why I have choose this depreciation method? Because the robotic arm is lying under the electronic equipment class. So therefore I have choose this. So if we see from this table that the value of the depreciation in the early years of the life of the project are greater as compared to the end years of the life. So greater the depreciation be, smaller would be the taxable income. So the depreciation method for the alternative way, that is the semi-operated or robotic arm that I have selected, is the straight line depreciation method. So in straight line depreciation method, the formula is as given, that is that the initial investment minus the salvage value divided by the life cycle of the, or the number of the years of the life of the project. So here the initial investment for the project A is 82,000 rupees and its salvage value is 2,000 rupees. So the total number of years are 7. Then manipulating these values into the formula, we got a depreciation of 11,421. It's a constant value. It will be remain same throughout the life of the project. So here is the cash flow after tax analysis for the alternative B. Here the first column is representing the years. The second column is representing the initial investment as well as the salvage value for the project. The third column is the of the gross income. Here the gross income is just I have assumed for this project. The annual expenses are including all the indirect costs, the labor cost, and the operating and the maintenance cost. The depreciation method that I have selected was the modified accelerated cost recovery system, that is the MACRS depreciation method. So here it is mentioned the percentages of the depreciation. So the depreciation is amount is representing in the next column. The taxable income is represented in this column, and the tax amount is calculated by multiplying the taxable income with the 30% tax. So the cash flow after tax is represented in the second loss column, and the cash flow after tax is just calculated by subtracting the cash flow before tax with the tax amount. Now, in the similar way, the cash flow after tax analysis for the alternative A is given as. So here the first column is representing the number of years. The second column is representing the initial investment as well as the salvage value for the project. So the gross income and the annual expenses are just calculated depending upon the number of operators who are using the manual operated arms. And the depreciation method that I have selected for this project is the straight line depreciation, which includes the initial investment minus salvage value divided by the number of the years of the project. Here the tax amount is just calculated by multiplying the taxable income with the amount of tax and the tax rate. The tax rate is considered for this project is also 30%. So the cash flow before tax is mentioned in the second last column, and the cash flow after tax is just calculated by subtracting the tax amount from the cash flow before tax. Since the projects are mutually exclusive, therefore I am adopting the non-sum criteria in order to find whether which project is economically feasible. So here I have mentioned the cash flow after tax of both of the projects that I have mentioned below. So I have arranged these projects according to their increasing initial investment. So the project of robotic arm whose initial investment cost was higher, that was about 1,85,000 rupees. That is placed on the extreme right side, and the project whose initial investment cost was lower, it is placed at the extreme left side. Then I made the incremental cash flow series, and then after this I will calculate the present worth of this series by plugging in different values of interest. In this slide, I have mentioned the present worth of the incremental cash flow series. Here I have just plugged in or put it the different values of interest in the incremental cash flow series and then finding out the value of present worth at that particular interest rate. So here what we see from this table that at an interest rate of 35%, the present worth of the project is 6,695 rupees. And then when we plugged in 40% interest, the present worth becomes negative. So what we conclude that the internal rate of return or the ROR is between 35% to 40%. So from the previous analysis, it is pretty sure that the present worth of the series would become equal to zero at an interest rate between 35% to 40%. Then I just have used the Origin Pro software in order to generate the graph for those results. And then when I plotted that results, I got an interest rate of 38.8% at which the present worth of the series becomes equal to zero. The minimum attractive rate of return for both the projects was considered to be 25%. As we do the rate of return analysis on the incremental cash flow series, we just found that the rate of return was found to be 38.18%, which is much higher than the minimum acceptable rate of return. So from there we can also conclude that the project of investment in robotic arm is much economical or much feasible than the project to reinvest in the manual or semi-operated line. So here I have also calculated the present worth of the both alternatives. So here we can also see that the present worth of the project that investment in robotic arm is much higher as compared to the present worth of the project in which we reinvest in the semi-operated or the manual operated line. So the present worth that we calculated is 6,72,317 rupees for the robotic arm. That is much higher than the 5,03,500 rupees for the manual or the semi-operated line. For doing the sensitivity analysis, I have to select a sensitive parameter. So for this purpose, I have selected the annual operating cost as a sensitive parameter because we know that the cost of operation for the robotic line is much higher as compared to the cost of operation for the manual or the semi-operated line. So the actual values of the annual operating cost for both of the projects are as given that the annual operating cost for the manual or the semi-operated line is 5,000, and for the robotic line the annual operating cost is 50,000. I just have increased and decreased up to 20% of the annual cost of both the projects and then calculated the present worth and see the effect of increasing and decreasing the annual operating cost on the present worth. So here are the results of my sensitivity analysis. I have variated the annual operating cost for both of the projects and see the variation of annual operating cost on the present worth. So here the very first figure is representing the annual operating cost variation on present worth for the semi-operated line, and the second figure is representing the present worth of the robotic arm with the variation of annual operating cost. So as we just decrease the annual operating cost for the manual or semi-operated line up to 20%, we see that there is a small increase in its present worth. And as we increase the annual operating cost up to 20%, we see that there is a small increment in its present worth. So when we move toward the second figure that is related to the robotic arm, then as we decrease its annual operating cost up to 20%, we see that the line is more steeper. It means that the present worth is getting much higher. And then as we increase its annual operating expenses, we see that there is a decrease in there is a greater decrease in its present worth. Now it's the time to conclude the economic analysis and make a final recommendation for the company. So starting from the very first point, that was the calculation of the internal rate of return. So what we concluded that from the incremental cash flow series, that at which the present worth of the series was become equal to zero, the interest rate was nearly 38%. So the minimum acceptable rate of return for this project was considered as 25%. So hence the internal rate of return or the break-even rate of return for the robotic arm is much higher as compared to the manual or semi-operated line. So the conclusion from the first point is that we can invest in the robotic arm. Then I calculated the present worth for both of the projects. So from the present worth analysis, it was also quite sure that the present worth of the project of the robotic arm was much higher as compared to the present worth of the manual or semi-operated line. So from the second point, it was sure that we can invest in the robotic arm. Now the third analysis that we did was the sensitivity analysis. So from variating the annual operating cost and checking the present worth, we also concluded that with the variation in the annual operating cost, there was a great increase or decrease in the present worth of the robotic arm project. So by having a great control over the annual operating cost for the robotic arm project, we can improve its present worth. So I will recommend the company to invest in the robotic arm project. The most important thing in engineering economics is to make a balance between the economics and the ethics. Sometimes if we may want to invest in a project that seems more profitable but is having negative impacts on the lives of the people. If we take an example of investing in a coal-fired power plant or a thermal-fired power plant, the emissions of the from the plant are causing acid rain and having a negative impact on the lives of the people. So what should we do in that case? So here our goal or purpose is to make a balance between the making money and doing the right thing. Now the point is that how to make a decision in such situations. So here I have highlighted some points. First, we have to make a list of the advantages and disadvantages of investing in the project. Then we should think about the negative impacts of investing in the project, like how it is harming the lives of the people and what are its long-term effects on the society as well as on the nature. For observing the impacts of any project on the environment, we can use different tools or softwares. These tools or softwares are used by most of the researchers and analysts. The most common example of it is the Homer Pro software. This Pro software also do the economic analysis as well as calculate the emissions of any project. Like if we want to project a diesel power plant, that how much of the carbon emissions will be from the power plant. So the responsibility of the engineer is to make choices that are fair, safe, sustainable, not just cheap and profitable. Now I will discuss about how the previous case study that I just have learned from the Open Learn course is directly linked or related to the program learning outcome number 11 that is under the course engineering economics. So the very first objective of the course that I just have learned and studied on the Open Learn software was to develop the understanding of the fundamental principles and the concepts of the cost accounting and its role in organizational decision making. So basically in this course, I just have studied about the different cost accounting principles, and then by learning those cost accounting principles, I just have applied those principles and the formulations, kind of formulations that I have studied into a real-time scenario to discuss the relevant deficiencies of the problem. And then the second objective of the course was to learn and how to identify, classify, and analyze the different types of costs, including the fixed cost, the variable cost, as well as for the effective cost control and management. So as I have just discussed previously, for the two different kind of cases, for the first option that was related to the like by implementing just the manual line and by doing the kind of maintenance, and there was also a second option in which we can use some kind of robotic arms, and we can some kind of we can implement some kind of automation strategy, or some kind of automation or digitization into the process line. So I just have separated up from both the options the kind of costs that were associated with the both options. The very third objective of the course that I have studied is to apply the cost accounting techniques, the kind of techniques or the kind of methods that I just have learned in the course, to apply into a real world or real scenario problem. So the problem that I had taken, that I just have presented and explained previously, was related to a real kind of industry in which the two options were placed in front of the industry stakeholders. The first option was related to like process or go through with the manual line, and the second option was related to in order to add some kind of digitization, or in order to add some kind of robotic arms into the manual lines, so we can in this way they can update those lines. So I just took this problem, and then I just have break down into the steps that I just have mentioned here. So the very first step was related to the cost estimation. So I just break down the problem, the cost associated with the both options. Like if I talk about the very first option, the costs that are associated with are the like the maintenance of the line, the kind of the labor cost, maintenance cost, and the operating cost. And when I talk about the option B, that was related to the semi-automatic line, or the kind of line in which the robotic arms are also installed. So the mainly the cost was related to the initial capital. That was the most important factor, or the most important cost type that was required in order to bring, or in order to digitize that line. So the main cost in the option B was the initial capital investment, and then so on the operating cost of the robotic lines is also can be considered. And then secondly, I calculated the depreciation by the Macros depreciation method. So Macros depreciation method is basically the modified accelerated cost recovery system. So this is a method that is based on the 7 years, and we can calculate the cost recovery or of the any kind of system in just 7 years. And then after calculating the depreciation for both the options, I just find out the kind of taxes that were involved for both of the cases, and then I made the cash flow diagrams or the cash flow tables before taxes as well as right after taxes. So CF80 and CFBT, these were the kind of the cash flow diagrams that I just calculated with the addition or the with the accumulation of the taxes. And then right after calculating the cash flow before tax and cash flow after tax, I picked up the cash flow after tax table values, and then perform the break even rate of return analysis. So in the break-even return rate of return analysis, basically we are looking for the relevant interest rate on which the interest rate the present worth becomes profitable for the investors or for the stakeholders, or at what suitable interest rate the investors or the stakeholders will get their invested or initial capital in how many years. It basically it calculates this thing, and then after calculating the rate of return for through break-even analysis for both the options, then I performed the sensitivity analysis. So the sensitivity for doing the sensitivity analysis, the most important thing in this step was to identify the sensitive parameter. So what would be the appropriate sensitive parameter which can be considered for both the options? So after going through, I just picked up AOC, that is the annual operating cost, as a sensitive parameter, and then I just calculated the overall the effect of the sensitive parameter or the annual operating cost on the present worth or the present value of the both the options, and by just adding a 20% more into the by adding 20% more into the operating cost, and then by reducing the 20% of the annual operating cost, and see the effect how the present worth is changing with the variation in the kind of the sensitive parameter. So in this way I just summed up that the sensitive parameter is highly relevant or is highly sensitive to the present worth of the value. Like whenever I am changing the annual operating cost, the present worth of the both the options, like the option A, the manual handling line, and the option B, the semi-operated line, that was really highly variating with the variation in the sensitive parameter, that is the annual operating cost. So here is a list of the references that I have taken from making a presentation. The very first reference is of the book of the engineer economy. The second reference is about the link from where I have taken the images for creating a difference between the uniform and the non-uniform cash flow series. And the third reference is for the macros depreciation method. This was all from my side. Thank you very much.